Good morning, everyone, and this is Circular Dynamics lecture number 7. Do we remember what we did in the previous class, lecture number 6? What was the topic, what we were discussing in lecture number 6? Can anyone recollect that for me? What we were discussing in the last class? Online, offline? Anyone? I think most of you have come on offline mode. Yes, what we were discussing in the last class. I hope you remember it.
Circular motion in horizontal plane, sir.
Circular motion in a horizontal plane. Yes, I think that is correct. And I think we had discussed two problems where a block was moving on a horizontal plane. In problem number 1, the surface was smooth. And in problem number 2, the surface was rough. Am I correct? Was there were those two problems that we discussed in the last class?
Yes, sir.
Okay, so we would now proceed on to the next problem. And as I told you, the concept or the theory of solving the problem remains same. I will again let you know. Step number 1, draw free body diagram. Step number 2, resolve the forces along 3 axes. First is along the tangential direction. This is the direction in which the circular motion happens. It's always tangential. Second is radial. And third, if required, is the perpendicular direction, perpendicular to the plane of the circular path. And in this direction, always there will not be any force. Net force should be 0. That is the better way of saying it. Net force in the perpendicular direction has to be 0. And that is how you make equations. Then if required, which will require, we would have to make equation for work energy theorem or law of conservation of mechanical energy, which will be coming in the next class. In today's class, we will try to finish as much as possible in horizontal circle motion, and we would move ahead with the next problem. And I hope, and I have very strong notion that you should be able to solve this one. This will serve as a test sort of what we have learned in the previous class. So let us see if you can solve this one. It looks pretty similar, and every problem is similar once you understand what is motion in a horizontal path. So here the problem goes. I hope you have this sheet with you. I'd already sent this sheet in the soft form. I don't know whether you have got it in the printed form. Anyways, so the question looks like this, and I'll repeat it and I'll mark it. The important points: a block of mass m is attached to a spring. Instead of a string, we have a spring of spring constant k. Natural length is L. Other end of the spring is fixed. That is how it can move on a circular path. It moves in a circular path on a smooth surface with a constant angular velocity. Now, instead of velocity, they have given angular velocity. Doesn't matter. They are the same thing. Find the tension in the spring. Now, remember, sometimes in the exam, you would be asked tension in the spring. Don't worry about that. When we are talking about tension in the spring, we are basically talking about force in the spring. And you must remember the force in the spring is always K multiplied by X, where K is the spring constant and X is the extension in the spring. I hope all of you remember that. Sometimes you might encounter the term tension in the spring. Don't worry about that. Tension in the spring or tension in the string is a force. Spring is also a string. String is also a spring. So you can call that force in the spring as tension in the spring as well. So don't get confused. Force in the spring or tension in the spring, that is what you have to find out. All the things are given. You know M, you know K, you know L, and you know omega. So your answer should come in terms of these four quantities: m, k, l, and omega. Your time starts now. If you can do it on your own, it is very good. Else, I am always there to help you out. 1 minute, and your time starts now. So, anyone with any other answer? Do you need more time or shall I solve it?
Sir, we tried, but we are getting omega square L only, sir.
No.
Can you
Maybe
explain, sir?
you're not trying hard enough. I will explain. I don't have any problem in explaining, but you're not trying hard enough. How are you getting m omega square L? What is the How are you getting m omega square L? Can you explain that? How are you getting m omega square L? You don't have to do, I mean, to get this answer, you don't have to take 10 minutes. You can just say m omega square L. Just because m is mass, omega is angular velocity, and L you think is the radius of the circle. So you have not done anything in giving me this answer. You have not tried anything. You have just seen what is the centripetal force, and you have given me the answer for centripetal force, m omega square L. You have not done anything here. You have not used your brain at all. That is the problem. You have not used your brain. What did you think when you say this answer? Do you think the radius of the circle is L? Do you think that? Do you think that the radius of the circle is L? No, it is not L, and that is wrong. That is what you have to think. When you are moving it in a circular path, the spring will extend. It has to extend, because when the spring extends, then only you will have tension in the spring, then only you will have centripetal force. According to your answer, the spring does not extend. If the spring does not extend, who is going to give it centripetal force? Lord Krishna? No, Lord Krishna will not give it the centripetal force. Centripetal force has to come from the spring. So the spring has to get extended. And if the spring is extended, the radius of the circle will not be equal to L, my dear friends. Am I clear? Are you getting my point, bacha?
Sir,
Yeah, so that is wrong. You have not thought about it. Someone has to give it centripetal force, beta. Someone, not God, Lord Krishna, or Jesus Christ, or Prophet Muhammad. They are not going to give it centripetal force. There must be something that gives it centripetal force. This is spring force that is going to give it centripetal force. Spring force only comes when there is extension. Your answer, there is no extension. So your answer is wrong. Try again. I'll give you a minute. It's easier for me to solve the question and then ask you to note it down, but that will not serve any purpose, because then you will be dependent on me solving the question rather than you attempting it. And that is a wrong practice. I see most of the boys are talking and chit chatting, and I hope that you can start on working out the question. Girls are trying at least. I'm always more proud of girls than boys. Boys are less sincere, and they are only doing all sort of mischievous things, which I can see right now. Ma'am is trying to make a point there, and I hope you are going to do it. So I'll give you 1 more minute. M omega square L is not correct, and I gave you the reason for that. 1 more minute. Try it. Else, after a minute, I would do my part. Chalo then, let us start solving this problem. So the first step is that I am going to draw a free body diagram. Yes or no? If I have to draw a free body diagram, I have to draw all the forces that are acting on this block. Now remember, this motion is happening on a horizontal plane, this plane, horizontal plane, this plane, table and horizontal plane. Now, this is origin O, center of the circle. Then, if it has to move in a circular path, there must be something which is providing it with the centripetal force, and that is the tension in the spring. Let me call that as F or T. I'm just calling it as F. And now this F is equal to K into X. K into X, where X is the extension in the spring. Where X is the extension in the spring. So I am assuming here that the spring gets extended by an amount X. Now, if the spring gets extended by an amount X, can anyone tell me what would be the radius of this circle? And that was the main point of this entire
X,
question. What is the radius of the circle now?
L plus X.
Yes, it is L plus X, as simple as that. It is L plus X. And as soon as you understand this, voila, you have actually solved the entire problem. I'll go step by step. I have drawn the free body diagram. I've just drawn the force in the spring. There are two more forces that I need to draw. But again, in this diagram where the circle is drawn vertically, I cannot draw the weight. I cannot draw the weight, and I cannot draw the normal reaction. So what I'll do is I will change the point of view, and now I will see this block as moving like this. Do we understand this, everyone? It is moving in horizontal plane. This is M, and this is my spring. The force in the spring is here in this direction. Do we all understand this? Yes or no?
Yes, sir.
Okay. Then you have the mass of the
MG.
block, mg, weight of the block coming down, and the normal reaction going up. We understand this? Normal reaction going up, n. And it is moving in a circular path, so it will be going in and coming out. I am assuming here that it is going in, so I have put cross and I have put omega. So far, so good.
Sir.
The first equation is that I make equation in the tangential direction. What is the force in the tangential direction? It is moving like this on this circular path. Is there any force acting along this horizontal plane in the tangential direction? Is there any force? Remember that this is moving on a smooth horizontal surface.
Zero, sir.
So there is no tangential force. Well done. So Ft is 0. We are done with the tangential equation. Let us move on to the second one. I'll use it as green. Let us talk about the centripetal force in the centripetal direction towards the center. Centripetal force in the centripetal direction towards the center. How much? Who is providing it with the centripetal force? Anyone? Who is giving this block the centripetal force to move in the circular path?
Spring force, sir.
Spring force, and that is, I have taken it as F, which is towards the center. Now this F has to be equal to Kx. Yes or no? Do we all understand this?
Yes, sir.
Now this Kx must be equal to what? This Kx must be equal to centripetal force. And how much is the centripetal force? Kx is the net force. That must be equal to m omega
square
square.
L plus X.
Yes, L plus X. That is absolutely correct. So I have got my equation. This is equation number 1 or 2 or whatever you call it. Solving this equation, solving this simple equation should give me the value of x. Can you now tell me the value of x? I am not going to solve it. You have to do it. Can you tell me the value of x from here? Can you tell me the value of x from here?
M omega square L by K minus.
m omega square L upon k minus m omega square. Am I clear with everyone in the class that this is the value of x that I'll get?
Yes, sir.
As soon as you get the value of x, you don't have to go any further because you have got your answer. Now I ask you, what is the force in the spring? And the answer is
Km omega square L by K minus M omega square.
just multiply this by k and you will get your answer for force in the spring. This much force must be there in the spring so that it moves around with a constant angular velocity omega. Can I have some raised hand that we have understood this from students in the online class as well as in the offline class? It was very simple. There's nothing you got to do. The only thing, the main point of this entire question, bacha, was to understand that the radius of the circle was L plus X. But wait, let us also solve the third equation. And the third equation is not required to be solved here, but it may be required to solve in the coming chapter. So you must be aware of how to write the third equation. Can anyone tell me?
N equals
What
to
would
mg,
the
sir.
third equation look like? Third equation is in the perpendicular direction, up down direction right now. What
N
is that
equals to
equation?
mg.
Yes, bacha?
N is equal to mg.
N is equal to mg. That is very correct. N is equal to mg. It is not required in this particular question, but if there was friction, this equation would have been required. So don't forget to make this equation as well, so that you remember that if it required, we have to make this equation. Right now it is not required. I'll give you a minute to note down this problem and the solution. If you have any problems, any doubts, I'm always here to clear them. A minute to win it, a minute to note it down. So if you noted down the solution and there are no doubts, let us move on to the next problem. And again, I'm hoping that you can give me an answer to this very soon. Again, you don't have to apply anything special. If you do simple things correctly, you should be able to give me the answer straight away. Remember, bacha, these are the type of problem that you are supposed to face or see in your exam. The problem that is coming is right now on your screens. Let us see who can give me the answer. Last bench students are talking. I don't know why. Last bench. The question goes like this. A block of mass m. Let me use my pen. A block of mass m, so m is known, is kept on the edge of a horizontal table. Turntable, you understand the meaning of turntable? Turntable is a table that can turn of radius r, which is rotating with a constant angular velocity omega along with the block. So the block is also moving on it. No, the block is moving with it. So you have a turntable and you have a block kept on the turntable on the edge of the turntable, and the block is moving with the turntable about its axis. So it is rotating like this. Dhar, 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 dhar. Coefficient of friction is mu. It is not given whether it is static or kinetic. Remember, static or kinetic. If it is not given whether it is static or kinetic, you just take both as same. If it is kinetic, use as kinetic. If it is static, use it as static. Find the frictional force between the block and the table. You have to tell me what is the frictional force between the block and the table. And your time starts now. I'll give you a minute to tell me the answer. The answer is already there, I think. I would like you to think about it and tell me why it is so. So, bacha, anyone with an answer? Anyone with an answer? I'll ask you one more question in this. Anyone has an answer for this? Well, the first thing that you have to understand in this question, which I'm going to ask as a question, turntable. This is turntable. This is a rectangular table. That was a circular table. Doesn't matter. So this turntable is turning, and I have okay. This will do. I have this. This is the block kept on this table, tongue like this. Now this turntable is turning, and obviously this block is also turning with the turntable like this, turn, 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 turn. They are both are moving together as what is given in the question, which is rotating with a constant angular velocity omega along with the block. So the block and the turntable, they are turning together. Now the question is, what type of friction occurs between this block and this turntable? Very evident to see. What type of friction is there? Don't get the question? What type of friction is there between the block and the turntable? Remember, the block is turning with the turntable. So what type of friction is there between the block and the turntable, and what is the answer?
Kinetic friction.
When does kinetic friction happen? That is the next question then. When does kinetic friction happen? Anyone? When do we have kinetic friction coming into the picture? No one remembers it? Sad. Anyone in the online class remembers when does kinetic friction happen? No one in the offline class also knows about kinetic friction? Well, as I keep on telling you, if you have this problem that Mr. Amir Khan had in the movie called Ghazni, where he used to forget what has happened 5 minutes before, you are not Amir Khan, so you will not be killing villain at the end of the movie. Right? The villain is your exam. If you call it the villain, if I take the example of that movie Ghazni, if you have this problem of forgetting everything that we have studied, it's going to be a big problem, because you will be finding it very hard to face the exam. We just did friction 2 months back. Remember, whatever we are doing right now, you are not going to appear in the exam tomorrow morning. You will be appearing in the exam at least after 1 year and 4 months, 3 months. That is the time when you will be appearing for exam, and obviously whatever I am babbling right now will make no sense 1 year and 3 months thereafter. If you have this problem, I suggest you better remedy yourself. Take some almonds. I might have told you, soak them in water overnight. Take them at the first thing in the morning. Have a glass of milk together with it. That will help in increasing your memorizing power, which is required at this point in time. Now, since I can't create memory and I can't make you remember everything that we have done in the previous 6 months, I'll just tell you in short that kinetic friction happens when there is relative motion between the two bodies. I cannot explain more. Static friction happens when there is no relative motion, but there is a tendency of relative motion. That is all I can tell you right now. Here, this block, where was this block? My block has disappeared. Yeah, this block is moving along with the turntable. There is no relative motion between the block and the turntable, and therefore the friction that happens between this block and the turntable, the frictional force F, this is static friction, and I will call it as Fs. and I'll call it as Fs. So this is static friction that is happening between block and the turntable. Now, as soon as it is static friction, we know that it has variable magnitude, it has variable direction. Now, right now, because of this static friction, and again, I will go back to the previous question. I will have to make equations along three axes. One is along tangential direction. Tangential direction, it is not moving in this direction. It is rotating with a constant angular velocity, and hence there is no force in the tangential direction. There is only force in the radial direction, centripetal direction, and that would be the centripetal force. And this centripetal force has to be provided by frictional force, because if there is no friction, if I keep this block on a piece of ice and then rotate the piece of ice, the block will not rotate with it because there is very less friction. The block might slip and it will just go away. It will not keep on rotating with the block of ice. So the only force that can give it centripetal force is my friendly force, frictional force. So this frictional force must be equal to the centripetal force. Remember, whenever you have static friction, you don't know the value of static friction. But here it is what is giving it the centripetal force. I know how much is the centripetal force. The centripetal force is equal to m omega square r, and that must be provided by the frictional force, which is static in nature. So the answer is static friction is the centripetal force, and the value of that static friction is m omega square r. Do we understand this? Can I have some reason that we understand this? To understand this, you must remember what is static
Sir.
friction. Yes, bacha?
Understood, sir.
If you understand, if you remember what is static friction, then only you can solve this question. If you don't remember what is static friction, this question cannot be solved. And hence, it is very important for you to understand that this is physics. This is not chemistry, may not be even maths. Maths also you require previous concepts in new chapters, but still they are very less. In physics, every chapter is related to each other. So we might be doing the last chapter of your course, but we might be utilizing something from the first chapter in that last question of the last chapter that we do. If you forget that first question of the first chapter, you cannot solve the last question of the last chapter or any chapter in between, and hence physics becomes difficult for you to understand. I hope you have understood what I have done here. Now my question is everyone, has everyone understood this, what we have done here? Can I have some raise hand that we have understood how I got the answer? Why is there static friction? Well done. Okay. You might have forgotten static friction, but we have now revised it. Now, my question is this, and again I will try to, where is my block? Again, I'll try to illustrate it. Now, I'm rotating it very slowly, so it will keep on rotating, as you can see. It will just rotate with it. If I increase the speed too much, and I don't know if I can do it, if I increase the speed too much, what happens? It cannot rotate. If I increase it too much, see, it will just fall. It will just slip. Just give me time. I need to pick it up. If I rotate it too fast, see, if I'm rotating slowly, it just keeps here. It just stays here. It does not go anywhere. But if I rotate it fast, see, gone. Gone. It slips away. Whoosh. That is the next question. What is the maximum angular velocity? What is the maximum angular velocity? What is the maximum angular velocity with which I can rotate it without it getting slipped away? You have to find the value of omega max with which You have to find the value of omega max, maximum angular velocity, with which the turntable TT can move or can rotate without the block slipping away. Without the block slipping. If I increase my angular velocity slowly, at some point in time, the block will slip away. You have to tell me at what angular velocity this block is going to slip away. Again, I'll demonstrate it. If it is slow, it just keeps on here. If I increase my speed, see, at some point in time, oops, gone. At some point in time, it will slip. You have to tell me that angular velocity at which it slips, and don't start doing this experiment and see how much it is rotating now. You can. This is not a question that has to be done practically. This is a question that has to be done theoretically. Your time starts now. A minute to win it. Let's see who does it. I hope you have tried the question. Now, with what maximum angular velocity can I rotate this so that the block and the turntable rotate together? At some point, the block will slip away. How do I get that velocity? Now remember, the only reason this block is turning with the turntable is because of static friction. Because of static friction, this block is turning with the turntable. If the turntable and my block, where is my block? If the turntable and the block are very rough, I can rotate it very fast. If the turntable and block are smooth, I cannot rotate it very fast because then it will slip. So basically, what is restricting my velocity is the friction force which is there between the block and the turntable. Now this static friction, which is providing it with the centripetal force, the static friction is always less than or equal to the limiting friction. The maximum value of static friction is limiting friction. Static friction cannot become more than limiting friction. And the value of this limiting friction is always equal to mu, which is this mu. I am taking it as mu s. I told you if mu is given, you can take it as mu s as well as mu n. So this static friction, the maximum value will be equal to limiting friction, and that limiting friction will be equal to mu into n. That is the maximum value of friction, static friction that it can have. Now I know that the value of n, how will I get the value of n? I will get the value of n from the third axis, n upwards, mg downwards. So this n will be equal to mg. Am I clear with everyone that this n will be equal to mg? Can I have some raised hand that we understand this?
Clear, sir.
This n will be equal to mg. Well done. So your maximum value of friction would be equal to mu into mg. Friction cannot become more than this. Now, if friction cannot become more than this is the maximum centripetal force that I can have. Centripetal force cannot be more than this value. So this is the maximum value of centripetal force, F max. This is the maximum value of centripetal force that I can have. If this is the maximum value of centripetal force that I can have, whatever speed this force gives me, whatever centripetal force, whatever speed I can move it with this centripetal force, that will be my maximum speed. So let me call it as mu max. So this F max must be equal to m into omega square max multiplied by r.
Sir, under root mu by r.
Where is g, bacha? You have forgotten g. This must be equal to mu into mg. You equate both the terms. And you will get the value of mu max. Can you tell me the value of mu max, anyone? And I would be very glad if you have understood this. This is one of the more difficult problems that can come in JEE Advanced, not main, JEE Advanced. What is the value of mu max from here? Equate both the equations and you will get the value of mu max. And that will be equal to under root of under root of mu times G by R. Do we understand this? Do we understand this? This is the maximum angular velocity with which I can rotate this turntable so that the block and the turntable rotate together. The block does not slip on the turntable. Can I have some raised hand that we have understood this? Boys on the left. Okay. So on this note, this was the last question for this class. We are dealing with horizontal circular motion on a horizontal path. 2 or 3 types of questions are still left, which we will cover in the next class. So by the end of next class, we would be done with circular motion in a horizontal plane. I hope you are understanding what is happening in the class. In any case, you can see this lecture once again. If you have any doubts, please come up to me. There are questions in this, 3 or 4 questions are left. If we complete everything, we should be able to solve those questions. You can try those questions at home. If you have any problem, any doubt from today's class, yesterday's class, or any class in before, you can always reach out to me through your Telegram. Let me wind this class here. I hope that you stay safe, stay in your hostel, stay safe, get vaccinated, and beat this coronavirus, and keep on studying. And don't become Amir Khan of Ghazni, because that is not good for you. So I'll see you in the next class. Till then, take care. Have a nice day. Bye bye.
Bye, sir.
Bye, bacha.